Okay, so this little video is on ATP. I'm really hoping I don't run out of battery now. You can see it getting lower and lower and lower. So, ATP. This is our energetic nucleotide. So, nucleotide, remember, sugar, base, and in the case of ATP, 3 phosphates, which we can abbreviate to pi. I know that's a sumsy sort of term. And ATP will give off energy if that bond is broken. And it will provide, we break that bond, we're going to release the terminal phosphate. We're going to be left with, I'm just going to draw it the other way around now, just to annoy you really, the ADP, which is adenosine, adenine and ribose diphosphate. So this is AD, that's ATP, and what we will get out of that is 30.6 kilojoules per mole of energy. So that's all very well if you need some energy to do something, contract a muscle, transport something across a membrane by active transport, pump a sodium ion out of a cell and a potassium ion in. That's great, we can use the energy from breaking that bond. But somehow we've got to get some ATP back, it's our energy store, and of course in mitochondria, as we know, they manufacture ATP. So here we're doing exactly the opposite reaction. So we're taking energy, ADP and phosphate, and making ATP. Where do we get that energy from? We get it from reactions of respiration. And you'll be doing those in a lot more detail when you do a component 1, and that's really something to look forward to. So this kind of reaction is an endergonic reaction. That's just a bit of a chemistry term. It means it consumes energy. We're using up that energy to make this. And the opposite of that is an exergonic, giving energy out. So it's exergonic going that way. Now obviously the reactions of respiration, by definition, they're giving the energy out to do this reaction. Respiration are also exergonic reactions. They're giving out energy. So, why is ATP so important? ATP is so important because it is what we call the universal energy currency. Universal means that it will, so what this really means is, if you were to define it, it's going to provide energy, the energy bit, to all reactions in all cells. So every cell that uses, so this all reactions, all cells, is this idea of universal. So bacterial cells use ATP, fungi cells use ATP. And the idea of currency really is the idea that you can use it and remake it. For example, I've got some currency in my purse. I've not got much, to be honest. I can spend it, And while I'm sitting here making you lovely YouTube videos, I'm also earning it, which is absolutely excellent. If only the two things balanced out, it would be super. Obviously in the cell, this does balance out. So if you need a lot of ATP, then you do more respiration so that you can make more ATP, so that you can use more, and that it is pretty a balanced thing. So why is it so useful? It releases energy in usable quantities. So, you know, one ATP molecule will provide enough energy to do a little reaction. So it releases energy in usable. I'm going to use the word amounts there. Hey, throw caution to the wind. So usable amounts. It's just providing enough energy, not too much that the cell would, you know, be overheating, because of course one of the byproducts of reactions is heat. So we're just going to release it in a very usable little amount, really useful. It is small and can cross cell membranes. Now that's handy because obviously it's being made inside mitochondria, it's got to get out and into the cell, so it can cross cell membranes. And be transported around the cell to where it's needed. And we can remake it. It can be remade as required. So the only other two things that I think you should know is if we're breaking this bond, it's not going to just sort of, you know, spontaneously break and release some energy. You need an enzyme to do that. If we're breaking, we're using an enzyme called ATPase that will break down ATP into ADP and phosphate and release the energy. If we're making it, we're going to use the enzyme ATP Synthase. Now, when you're watching American videos, they'll call this ATP Synthase. The WJEC and therefore EduQuas are really quite insistent that it's ATP Synthase, so you really need to remember to put that Synthase in. Okay, so you need to know the equation, you need to be able to explain what universal energy currency means, and you need to explain how the properties, so these are these, structure, that's that reaction, and formation of ATP are linked to its roles in cells, so it's providing these energies to all the reactions. So that kind of covers part D, I think C and D of your tip list, your teacher's guide.